Hi, my name is Daniel Slotnick, and my study is a materials comparison of vinyl sheet, luxury vinyl tile, vinyl composite tile, and linoleum flooring in reducing head injury severity from falls by children. So, I volunteer with kids with disabilities as well as babysit in my temple, and I've seen that many children fall out of their chairs or just fall in general, hurting themselves, and this prompted me to come up with ways to make these environments safer. So I researched more into this and found that it's an actual widespread problem. In fact, 2.8 million children visit the emergency room for a fall related injury each year. These injuries range in severity from non significant to traumatic brain injuries, which can sometimes even be fatal. 82% of all falls generally occur in high traffic areas such as schools and hospitals. Furthermore, the leading injuries that result from falls are actually head injuries. Several studies have also found that there's a correlation between the surface onto which a fall occurs and the resulting injury from that fall. However, no study has yet proposed a scientifically rigorous method to test different flooring materials and their ability to decrease head injury severity. Therefore, that's exactly what this study did. Vinyl sheet, luxury vinyl tile, which is also called LVT, vinyl composite tile, which is also called VCT, and linoleum were chosen as the four experimental groups because they are the most common flooring materials used in high traffic areas. The main research hypothesis of this study was that vinyl sheet would be the best flooring material to increase total collision time and therefore decrease head injury severity, and by decreasing head injury criterion and peak impact force. I also made two predictions. The first one was that the flooring materials' peak impact forces would be statistically significantly different from each other and from the baseline. I also predicted that head injury criterion and peak impact force would be strongly correlated. I utilized two methods to test these hypotheses. In the first method, peak impact force generated by 50 collisions on each flooring material was recorded. Peak impact force, also called Fmax, is the highest recorded force in a collision. Scientists have found that decreasing Fmax reduces fall related injury severity. To compare how much each flooring material decreases Fmax, percent impact attenuation was calculated. This equation is significant because it allows someone to find out how much a material decreases the force generated on impact in comparison to an impact with no material, which is also called the baseline measurement. I constructed a dropping apparatus to control for fall height. This dropping apparatus, which is pictured in Figure 1, released a cannonball weight representing a child's head onto each flooring material, which was placed on top of a force sensor that recorded the Fmax for each collision. In the second method, I 3D printed anthropomorphic heads, which were dummy heads. They were dropped onto each flooring material, and the acceleration of the head during impact was recorded. The process for creating these anthropomorphic heads are shown in figures 2 and 3. I coated the anthropomorphic heads in a chemical called Ecoflex to simulate the viscoelastic and compressive properties of human skin, and I also added modeling clay in the inside of this anthropomorphic head to closely model the features of the brain and inside the head. The acceleration graphs created by each collision were used to calculate head injury criterion, or HIC for short. The equation for HIC can be seen in Figure 4. HIC is known as the current gold standard in finding the risk of head injury in a collision. A low HIC score corresponds to a lower risk of head injuries resulting from a fall. HIC was modified by me, as seen in Figure 5, in order to represent a free motion head form. I further modified the HIC equation in order to be compatible with the raw data. It can be observed in Figure 6 that average Fmax for vinyl sheet and the baseline are the highest, while average Fmax for LVT and linoleum are the lowest. It can also be observed that Fmax for vinyl sheet and the baseline overlap considerably. As hypothesized, t-tests found statistically significant differences among the four flooring types. However, contrary to the hypothesis, there was no statistically significant difference between vinyl sheet and the baseline. As you can see in As you can see in figure 8, linoleum had the highest impact attenuation at 13.8%, while vinyl sheet had the lowest at 0.26%. It can also be observed that linoleum had the lowest mean peak impact force at 601.5 newtons, while vinyl sheet had the highest peak impact force at 696. For the anthropomorphic head testing, raw data was converted into a graph of the resultant acceleration of the head over the collision time. As seen in Figure 9, the raw data was curve fit in order to be compatible with the HIC calculation. As you can see in Figure 10, linoleum had the lowest HIC at 175, while vinyl sheet and VCT had the highest HIC at 182 and 181. There was a calculated 72.75% correlation between the mean F max and HIC results. As you saw in the results, linoleum had the lowest peak impact force and HIC, while vinyl sheet had the highest peak impact force. Furthermore, peak impact force for vinyl sheet and the baseline was not statistically significantly different. I made a little table on the bottom of the screen. You can see that a lower HIC score is correlated with a lower peak impact score, which together are correlated with a lower head injury risk. So let's go back to the hypothesis. My first hypothesis was that vinyl sheet would be the best flooring material. However, linoleum was actually the best flooring material because it had the lowest HIC and lowest peak impact force. Now, my first prediction was that there would be a statistically significant difference between the flooring material's peak impact force and the peak impact forces compared to the baseline. Now, this may be true, and there was a statistically significant difference between all the flooring materials' peak impact force, and them compared to the baseline, except for the comparison of the baseline and the vinyl sheet. So we're going to give this an X and a check. My second prediction was that there would be a strong correlation between the two dependent variables, HIC and mean F max. And there was a 72.75 correlation between both of the results of both methods. So, in conclusion, linoleum is the best flooring material to decrease peak impact force and decrease head injury severity resulting from a fall. On the other hand, vinyl sheet will not significantly decrease head injury severity resulting from a fall, as there was no statistically significant difference between its mean F max and the mean F max of the baseline. Furthermore, HIC and mean F max are highly correlated, which reinforced the validity of the data and proved that these methods were effective. Some limitations that may have affected the results of the study are that HIC had to be estimated by curve fitting because exact computation takes a long amount of time where time was limited. Furthermore, the number of trials for the anthropomorphic head testing had to be limited to one because the anthropomorphic heads could not withstand several impacts. There was damage on the anthropomorphic heads only after only a few impacts. Furthermore, the anthropomorphic heads were very costly and took a lot of time, so I could not 3D print them very quickly, and therefore I could not print several heads. Future research is needed to calculate what properties of linoleum allowed it to perform the best in the current study. Furthermore, the methodology of this study should be replicated in order to validate the methodology that I propose. It's hoped that new standards in flooring material testing based on these methods can be established in order to minimize the millions of injuries in children caused by falls each year. Now, thank you to all these people, and thank you for listening to my presentation. I hope you enjoyed.